today's goal of this lecture, we all of us know metric space means distance between 2 points, which is denoted by d of xy. Today I will see distance between set, and this distance is infimum distance, and some question about this distance, infimum distance of a set. This is today's goal of this lecture. Let's see what is the infimum distance of a set. This type of question actually very important for any competitive exam. Okay, so I will highly recommend you please see today's video with pay attention, and if you have any queries in anywhere, please do comments in comments box. Okay, let's see the question. Question is, let A be a non-empty set of a metric space X and define a distance from a point X in X to a set capital A. Here, distance from a point to a set, and this distance such that d of xa equal to infimum y belongs to A d of xy. Then option 1, prove that if x belongs to a closure if and only if d of x comma a equal to 0. Option 2, show that absolute value of d of xa minus d of ya less than equal to d of x comma y for all xy belongs to a. Option 3, if prove that a contain b, then this is the opposite part, d of xb less than equal to d of xa. And option 4, show that d of xa equal to d of xa closure. See some example. X equal to r and a equal to minus 1 to 1. Here the picture would be such type. Here the set minus 1 to 1, this is a minus 1 to 1. When the point lies on a, then distance between the point would be 0. Other infimum distance, when the point not lies between the set, then the distance would be such type. So infimum distance d of xa, here a equal to minus 1 to 1 would be such type. Similarly, when x equal to r and the set a equal to, here the set a equal to natural number, at first just imagine how look like the infimum distance between the set. Here the point 0, 1, 2, 3, so on. Here minus 1, minus 2, minus 3, so on. So the picture would be such type. I hope my all viewers have understood. This is the d of a. This is also d of a. Here a equal to natural number. And here, here not n. Consider a equal to integer. So I have considered it also minus 1, minus 2, minus 3. If a equal to natural number, then only this part. I hope my all viewers have understood how the infimum distance between a set. Now I will see this exercise. First, very easy. If this is the if and only if condition, prove that x belongs to a closure if and only if distance between x and a equal. We have to prove prove if x belongs to a closure, then d of x is equal to 0. This is very easy proof by definition. X belongs to a closure means, and this is if and only if condition, for all epsilon greater than 0, b of x epsilon intersect a not equal to 0. This is not equal to 5. This is definition of a closure. That means this imply by from this expression we can write by distance function, for all epsilon greater than 0 there exists y belongs to a such that d of x comma y less than epsilon. Since d of x comma y less than epsilon, and this is true for all epsilon greater than 0, that imply infimum distance of d of x comma y equal to 0, and this is true for all y belongs to a. Therefore, infimum distance of d of xy equal to 0, and this is true for all xy belongs to a. So, if x belongs to a closure, that means infimum distance of y belongs to a, d of x comma y equal to 0. I hope my all viewers have understood. This is very easy type proof. Infimum distance of this distance y belongs to a, distance of xy equal to 0 means this is d of x comma a, where a is the set, equal to 0. That means this is if and only if condition. If x belongs to a closure, then d of x comma a, this is 0. Or if d of x comma a equal to 0, that imply x belongs to. Show that distance between x and the set A minus distance between y and the set A, these absolute value less than equal to distance between x and y, where for all xy belongs to A. This is also very easy type. Since distance between x and A means infimum y belongs to A, d of xy, this is the infimum distance. So, this proof is very easy. Let z belongs to A. Then, obviously, distance between x, A, this is less than, since this is the infimum distance, so obviously this is less than d of x comma z, where z is arbitrary number in A. And by triangle inequality, this is less than equal to distance between xy plus distance between yz. Therefore, from this line, we can write distance between xa minus distance between xy less than equal to distance between yz. Since z is a arbitrary number, so obviously this is also less than equal to d of xa minus d of xy. This is also less than equal to infimum of d of yz, and infimum of d of yz is nothing but d of ya. So, by this expression we can write d of xa minus d of ya less than equal to d of xy. And this is our goal of this proof. D of xa minus d of ya less than equal to d of xy, and this is true for all xy belongs to A. I hope my all viewers have understood this is okay. That is very easy, but many people would be wrong here. Here the question A contain B, but notice d of xb less than equal to d of xa. Since A contain B, but since here infimum distance, so infimum distance of d of x comma b, infimum of d of xy where y belongs to b, this is less than equal to always infimum of d of xy where y belongs to a. When there exists supremum distance, then a contain b means this distance always would be less than this distance. But since here infimum distance, so obviously since a contain b, that means b is the big set. So infimum distance of this value, this part is always less than equal to d in this distance. I hope my all viewers have understood. Okay. So infimum of the biggest set always less than equal to infimum of the smallest set. If this is the supremum, then if infimum of biggest set always greater than equal to infimum of smallest set. That means d of xb less than equal to d of xa. That means when the set is bigger, then distance between x and b always less than equal to distance between x and. That means when the set is bigger, then this distance always should be smaller from this distance. I hope my all viewers have understood. Next, I will see d of xa equal to d of xa. Since a contain a bar, that means distance between x and a bar always less than equal to d distance between xa. For conversion, epsilon greater than 0, then by property of infimum, let epsilon greater than 0, then infimum plus epsilon, this is not lower bound. That means there exists y belongs to a bar such that d of xy less than this infimum plus epsilon. Z belongs to a, therefore d of xa is less than equal to d of xz, and use triangle inequality d of xz less than equal to d of xy plus d of yz. Therefore, since I have got d of xy less than d of x a bar plus epsilon, this is less than d of x a bar plus epsilon, and here I have got d of yz less than epsilon, that means this is also epsilon. That means this is less than equal to d of x a bar plus 2 epsilon. Here I have got d of xa less than equal to d of x a bar plus 2 epsilon. That means d of xa less than equal to d of x a bar. Also I have got d of x a bar less than d of xa. So by these two inequality, d of xa equal to d of x a bar. I hope my all viewers have understood this is okay. Next, if we consider fx equal to this infimum distance, then always f is uniformly continuous on this x where x d be a metric space. And this is because few minutes ago I have seen d of xa, absolute value of d of xa minus d of ya less than equal to d of xy for all xy belongs to x. That means that imply d of ax minus d of ay less than equal to d of xy, and this is true for all xy belongs to x. That means dA is ellipsis continuous. Here we all of us know when fx minus f of y less than L times x minus 1, then f is ellipsis continuous. Here L equal to 1. So dA is ellipsis continuous. Since dA is ellipsis continuous, that implies dA is uniformly continuous on the set X. I hope my all viewers have understood this expression clearly. Why f is uniformly continuous, where f is distance function, in not only distance function, infimum distance function. Okay. Today I will stop here. I hope my all viewers have understood clearly today's concept. Today's concept is very important for higher study. Okay. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.